I'm gonna be solving this problem. Concatenate. So this is a contest. Let me make it light. I'm starting a bit late. Already kind of couple minutes in. So I'll start from this one and see how I'm gonna go. From the new integer x by concatenating. Explanation seems weird, but seems like this is just collapsed, like 102 collapsed to 1 2, but there is still 0. Form a new integer x by concatenating all the 0 digits of n and the original order. If there are no digits, x is equal. Let the sum be value of x multiplied by sum. X multiply. So sum of, okay, so I also should have a counter for the digits. Okay, so I'm gonna go while, let me make it bigger. So while n is greater than 0, I'm gonna go, and I'm also gonna have original, let's say concat goes to 0, so I'm gonna go while n is then not is greater than 0, and then sum, and then like x, or like sum is equal 0, and then x is equal 0, and then n digit equals n mod 10. If digit not equal 0, I'm gonna go x equals x multiplied by 10 plus digit. Then I'm gonna go sum is equal plus equals sum plus equal digit, and then I'm gonna return, and then I'm gonna divide n equals n divided by 10 mod, integer division by 10, and then return x by sum. Output 4. And also, like, I didn't save the order, so it's reversed now. I can do the list, actually list here equals, or I can keep multiplying by 1000, like let's say mult equals 1, and then x plus d mult, and then I'm gonna go mult equals 10. Okay, that works. This one output should be here 1. Okay, let's submit. Okay, next one. So you are given an integer array nums. The strength of the array is defined as a bitwise OR of all its elements. A subsequence is considered effective if removing the subsequence strictly decreases the strength of the remaining elements. Subsequence is an empty array. So we have here again array of integers. So nums. Oh, bitwise OR of all its elements. Okay, a subsequence is considered effective if removing that subsequence strictly decreases the strength of the remaining elements. Return the number of actual subsequences and nums. Okay. So the total subsequences can be quite huge. Given number. Okay, I'll think about this problem. Okay, let's start with this one. For each query, extract the substring. So how many queues and how many? So so string plus still. Oh, so it should be so queue queries is like 10 to the power of 5 and the length of the string is 10 to the power of 5. So I cannot just have a linear one. Linear algorithm. So for every query, just apply the same algorithm that was in the first task. So queries LIRI. How I can optimize this one for the multiple queries? So I have a formula. So I need to. So the sum can be found pretty fast. So I need just a prefix sum and suffix. Prefix sums, and the number itself. It's a difficult one. So it's always 10 to the power of 5, and then can be 10 to the power of 9, and then can be 10 to the power of 5 numbers. But some can also be huge, that's why multiplying the number itself. Oh, the length, even the length can be huge, like it's... So the length here is, let's say here is like not that big, but yeah. So prefix sum is easy. How I can get the efficient this concatenation? This and you need this probably. Yeah. What say? What say?
Зарядку мені дай.
Mom, this is all fast.
So I need somehow to get the number concatenated. And do that pretty efficiently. And then, are there any conditions? Oh, I can have just what, last 9 digits, and save them, something like this. Last 9 digit for the... Yeah, so the idea is like, yeah, the idea is last 9 digits. So like, let's say I have 1, 0, 2, 0, 3, 0, and 4. And say I have I save the last 9 digit for the every let's say we have not mod 10 to the power of 9, but like 7 plus 10 mod to the power of 9. but let's say 7 plus 10 to the power of 3. So it means that for the for the 4 I'll save 2, 3, 4. For the 0 I'll save Oh, I don't need to save it. I'll just gonna go like 9 numbers like to the left for every, it's gonna be 9 to 10 to the power of 5. So basically 10 to the power of 6. I need to go just 9 or 9 numbers, or maybe a little bit more because there are gonna be like zeros to the left, and then also I need to control for the left bound, and then I'm gonna like assemble it, and then for every, let's say, range, I need to go from right to the left side and need to take just 9 numbers, and up, maximum 9 numbers that are not zeros. And then I can calculate the prefix sum beforehand, and then calculate the sum in this range, and multiply one by another. So the operation here is like, how many people saw this? 2000. Okay, so for I, let's go prefix equals a list equals, let's say, multiply by, let's say, len n equals len string, and then prefix equals and then for I in range n, go prefix I equals prefix if I greater than 0, if else. So it's gonna be s char at I minus a, and then this one gonna be minus order of a, and then here s mine if else, if else, okay, if else, if I minus 1 greater or equal 0, just I greater than 0, then prefix I minus 1, otherwise else 0 plus this one. So this is going to be prefix sums, and then I need to go mod equals 10, 10, say Google Python 10 to the power of 9 shortcut. I can do this. Can I do that in a different way? Like, is it a way how to do that? No? Then okay, I should go 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then last one 7. and then I need to go mod, and then I need to go and create this list of numbers. Okay, nums all digits equals this one multiplied by 0 multiplied by n, prefix 0 multiplied by n, and then digits I, it's gonna be order I, this one basically. So it's gonna be num here. Okay, let's go nums, call it nums, then nums. Okay, and then for every query for q in list, okay, in range, so I'll say qn equals len queries range qn. I need to, and also I'm gonna have result equals 0 multiply k0 multiply by qn, and then for every query I need to go so the sum gonna be prefix, so left gonna be q0 or like queries q 0, and then right gonna be queries q1, and then sum gonna be just prefix of prefix of right minus prefix of left minus 1, or yeah, and then prefix of left minus 1, then if I minus 1 greater than, if I greater than 0, else 0. So this is gonna be the sum. The multiplier, so I need to add also mod here. Mod plus this one minus that one, and then add mod. And then for the x, I need to go to figure out what the x here, and then I need to go for I in, let's say I in range right to left minus 1 minus 1, and then I need to just accumulate. So x initially gonna be 0, multiplier gonna be 1, and then here I'm gonna go x should be x plus multiplier multiplied by nums I, and then I need to multiply multiplier, and then I need to go result as q equals x multiplied by sum, and then this one should be mod. This one also I need to just check 9 numbers maximum. So let's do this. Pointer equals right, while pointer is greater or equal left, and let's say equals 1 equals 0, and arc less than 9. I'm gonna go so pointer gonna be pointer minus minus arc, and then I need to check if nums I not equal 0, I need to go arc plus 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 equal 1 minus equal 1 arc plus 1, and then I need to do this operation x equals, and then multiply by 10 multiplier, and then result here gonna be just this one multiplied by sum mod, and then I need to just return the rest. Okay, let's run and check how it's gonna work. Prefix, okay. And here okay. No, not true. 0, 7. Let's debug it. Why it is out of range? I don't understand. Prefix I equals prefix I minus 1 plus num and then mod. Okay, maybe it's okay, order 1, order 0. Still not matching the result. Should be the first one. So the query is matching right now 2, 3, 6, 10, D and 10. Okay, prefix sum is fine. So result this one. So Q in the Q range, left and right. Left and right. Left gonna be 0, 7. Okay, let's print sum. Uh-oh. Oh, prefix L minus 1. Oh, yeah, I'm right here. So the sum is 0, and it shouldn't be 0. Why? So print prefix, gonna be prefix. Let's run it. So sum here from 0 to 7 should be not should be 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. Should be 10 minus 0 if L that's a huge number, big huge number, 49. Okay, mod. So what's gonna be the sum here? Sum should be 10, okay, and the number itself, so print x, let's say f, x gonna be x here. So print x 444, y 444, pointer. Why I'm stuck with this I? Maybe I should start using that I. X if num's pointer not equal 0. So 1, 2, 3. Yep, let's do this. Let's do this. Comment, comment, comment. 4, 9. Is it 4, 9 here? Yep. And here 1, 0. And here long. Okay. I'm getting random numbers here. What if I'm gonna do like 12, like 20? No. What if I'm gonna comment this one and run it? Yeah, obviously, time exceeded. Yeah, time limit exceeded. 20. Maybe, so I already tried 20. 30. Yeah, something I'm missing here. This is really long number, and for the query for this one, it is, oh, no, 1, 2, so it's 1, 2, okay, close. 1, 2, 3, 4, 5, 6, 7, 8. Oh, what I'm counting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So here, 1, 2. Let's say my initial assumption was it should be less or equal 9. So this, I assume that this should be fine, but it wasn't. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. From 0 to 10. And for whatever reason, the mod is not happening here. So 0 to 9. Zero, 1, 2 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's entire number, and if I do the entire number multiply by sum, let's say I'm gonna be print this one. she 16, what, 69, okay, 69, adding all numbers, and the number itself is this one, what's gonna be multiplied by 69, print. So it should be did I got it wrong? Okay, let sum be the sum of digits sums, right? X by sum. So from 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X by sum. Why is this not adding up to the 9th? This. If I do mod okay, so the mod okay, let's print x here. So 0, print, let's say q, and x. So q, I'm looking for q equals what? Q is equal 10. No, 0, 1, 2, 3, 4, 5, 6, 7, 8. Q is 8. Q is 8. 6, 7. Yeah, but why it is not what it says? When I do the mod, is it that because of this operation? No, not really. So it should be this 6, 6, 7, 8, 8. Q. No. Q 5, 6, 8. X is this one. Is it matching? 8. So it is 8, 5, 7, 8, 8, 3, 3, 9, 8, 5. It's matching. Okay, 10 to the power, let's say 10. Somewhere I'm accumulating this error. So now so it's 0, 1, 2, 3. Let's use this use case. Use case. Can I use it? I cannot use it. Use test case. Okay. And what? Why I cannot add it back? Queries. Use case. Okay, copy. Something is not working right. Whatever, like, let's do this one. So it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, Q8, 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 Q8 is here. And then 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 11. 0, 1, 2. So I keep. So somewhere this operations are not kind of this assumption that multiplying one by another and keeping just the module. So if num's pointer not equals 0, and then so AKK here should, so the number is this one, and then Q8, and then I'm perfectly fine saved the first 10 digits. Yeah, and when I do 10 digits multiplied by sum, okay, print this one plus this one plus this one plus this one plus this one, this one, this one, this one, this one, this one, and then I need to multiply the number itself by the sum. Say if Q equals 8, I want to print it only in this case. So this number, if I add it up 63, if I do this one, and then 63, and then separately print this number multiplied by 63, and then print this number 63, and then might be this one, maybe it's like I don't know, the order matters. What? Okay. So this and this number should match in theory. But they are not matching. Oh. What should be the right answer? 988. I got when I do the shorter version and multiply it by 63 and do mod. So it turns out like any mod will not work here, and I cannot safely use it. Seems like true. But what should be used here, and what operation will... I thought that like I can pretty safely use a mod here. Given a string S of length m consistent of digits, you are also given a 2D integer array of queries, where queries equals LI, RI, for each queries extract the substring SLI, RI, then perform the following. If there are no zeros, okay. To the power of 9 plus 7. What if I gonna put it like ridiculously big number, let's say 25. I still cannot wrap my head around like why it is that important. Yeah, it seems like it's like now it's like failing with the 25 digits number. Yeah, I'm gonna stop recording. Seems like managed to only solve one easy problem. Um, yeah, that's gonna be it.